Welcome to part 5 of our presentation on variable speed injection mixing. I'm John Barba, and in our last segment we learned about the versatile Taco 00VR variable speed injection circulator. Now in part 5 we'll take a look at another way of providing variable speed injection control, this time using Taco's expandable relays and the PC705. Let's get started. As shown in part 4, the Taco 00VR is a very easy way to provide delivery reset. Our job could be handled very nicely with 3 00VR circulators, one for each water temperature. Wiring and boiler control is pretty simple as well, especially if each water temperature is one single zone. However, if each water temperature has multiple zones, which is a real probability with Radiant, there may be a better solution. Also, what if you wanted some other stuff? What if you wanted intelligent boiler control? When using the 00VR, the boiler will fire whenever there's a call for heat. Now that's not bad, especially with a relative low mass boiler, but again, there may be a better solution. And what if you wanted to add other options as well, including intelligent domestic hot water priority, boiler reset or boiler staging, or even boiler post-purge, the dumping of excess heat left in the boiler into a priority zone, such as a domestic hot water tank? And how about pump exercising, or simply running the pump for a few minutes every week or so during the off season? Oh yes, and let's not forget what we're here for in the first place, the actual injection mixing control. Doing all or even some of this can be fairly cumbersome when you're trying to mix and match all these different components. It can be kind of difficult to get all these different things, these different color boxes, to play nice together in the same sandbox. But there is an option out there that can make it all very easy. The Taco PC705 injection power control in conjunction with Taco expandable zone controls for zone valves or expandable pump relays for circulators. When using these components, we can easily incorporate zone control, boiler control, and injection mixing control into one simple, easy to understand, easy to wire package. It can make putting this system together almost fun. The PC705 is an injection reset control, and it can be plugged right into one of the expandable zone controls to easily integrate with the rest of the system. The control comes with a Molex connector, as you see here, that plugs right into the power control slot of the expandable relay or the zone valve box. Couldn't get much simpler. The PC705 provides full injection reset, controlling the injection circulator, a standard 00 series wet rotor circulator is all that you'll need, and there's also a provision to fire the primary circulator if needed. In a larger system, however, it's conceivable that the primary circulator would be controlled by the powered zone control boxes. One of the neatest things about the PC705 is that not only does it provide injection reset for the heating delivery, it also provides intelligent control for the boiler by managing the boiler's firing cycles. While not providing actual boiler reset, the PC705 can manage the boiler's differential so that it won't short cycle. It automatically calculates the appropriate differential and automatically calculates the required boiler supply temperature based on the load on the delivery portion of the system at any given point in time. This will greatly enhance overall system efficiency, while preventing short cycling will also extend the lives of all of the moving parts on the boiler, thereby reducing your maintenance costs. This diagram represents a multiple zone radiant floor heating system zoned by circulators. Note the 4 zones on the secondary piping portion of the system. Those circulators are all wired into a Taco SR504 EXP 4-zone expandable multi-pump relay. The PC705 is wired into the expandable relay as well using the Molex connector, and also note that the injection circulator is wired to the 705, as are all of the required sensors. First, there's the outdoor sensor, which is placed on a north-facing wall out of direct sunlight and above the snow line. The radiant supply sensors on the radiant supply piping on the secondary side, and its job is to monitor the water temperature being delivered to the radiant system. And then the boiler sensors strapped to the supply side of the boiler piping to monitor the boiler water temperature. Also note that the primary circulator near the boiler, as well as all of the system circulators, are wired into the SR504 as opposed to the boiler control or the 705. This means the boiler is not going to fire every time there's a call for heat, and it's not going to fire when the circulators fire. There's usually some residual heat left over in a cast iron boiler from the last time it was on. The control arrangement we're using here will try to use up that residual heat before asking the boiler to fire again. If there's enough heat left over in the boiler from the last time it fired to satisfy the heat demand, well, what sense does it make to have the boiler fire again? This control strategy will definitely overall enhance the system efficiency. When there is a call for heat, the zone circulator will fire as well as the primary circulator. The 705 will determine based on outdoor temperature and its programming what water temperature the radiant system will need, and it will fire the injection circulator accordingly. In this example, it's a little bit less than 25% of its speed. The boiler will also fire if necessary, and the 705 will automatically determine the correct firing differential for the boiler and the optimum boiler water temperature required for the injection to work properly. As more zones call for heat, more energy will be needed in the secondary side of the system, so the 705 will tell the injection circulator to speed up to deliver more BTUs into the secondary. The 705 will also continue to monitor the boiler, having it fire only when it needs to in order to satisfy the heat demand. Now, as the zones satisfy, the injection circulator will then slow down, and ultimately the boiler, the injection circulator, and the system will shut off. Here's a closer look at the wiring schematic for this system. The 705 is connected to the expandable relay using the Molex connector as shown. All the sensors are wired into the 705 as well, as is the injection circulator. Now this example shows the option of wiring the radiant system circulator if there were only one, or the primary circulator right to the 705. In this example, however, since we're zoning with circulators, all of those circulators will be wired into the expandable relay, as will be the primary circulator. There are two switches to note in the expandable relay as well. The first is the master-slave switch in the upper left-hand corner of the relay. The expandable relays are just that. They're expandable. That means you can piggyback more relays off of one if you need more zones. The master-slave switch allows you to tell the control which one is the master and which ones are the slaves, so that only one relay will need to be wired to the boiler, and only one relay needs to be wired to the primary circulator. If you're only using one relay, obviously you set that switch to master. The other switch that we're talking about is the reset normal switch, the mode switch. This controls what the end switch of the relay does. In the normal position, the end switch of the relay will close and fire the boiler anytime any zone calls for heat. In the reset mode, the end switch will only close when the 705 or any of the other add-on power modules tells the end switch to close. In reset mode, the end switch will also close when there's a call for domestic hot water priority, providing for your domestic hot water. In this example, the relay will be set to master, while the mode switch is set to the reset mode, and it's allowing the 705 to intelligently control the boiler for maximum efficiency. All of the thermostats are wired into the zone input terminals at the top of the box, and the zone circulators are wired to the line voltage terminal strips at the bottom of the box. Power is brought into the bottom of the box at the lower right-hand side, and you'll also note on the lower left-hand side of the box is the end switch terminal. These switches will be wired to TT on the boiler control. Next to that are the ZC and ZR terminals. By using the jumper across those terminals and then wiring the boiler circulator into the ZR terminal, we can turn on the primary pump even if the boiler isn't calling to pull out whatever residual heat may be left in the boiler before firing it again. Again, the point is to maximize the overall system efficiency. Well, that's just a taste of the Taco PC705 power control. In Part 6, we'll show you how to integrate the PC705 with Taco's expandable pump relays and zone valve boxes into an easy-to-understand control strategy for a multi-temp, multi-load hydronic heating system. I'm John Barba, and we'll see you next time.